Let's start with section 10.3, the inverse of the square matrix. So I'm going to start with the first questions. It says if there is an n times n matrix, a to the -1, this is the inverse for the matrix. So this is really important notes. This is the inverse for the matrix. And every time when A times the inverse is going to be the identity matrix. Then A inverse is, you're just going to choose the inverse of the matrix. That's it for this example. Let's go to number 2. Number 2, they saying a matrix has inverse. So this is also important. For number 2, a matrix has inverse. That has an inverse is invertible, or you can choose non-singular matrix. A matrix that does not have an inverse is a singular matrix. For number 3, a 2 times 2 matrix is invertible if and only if. This is really important because this is a theorem and we're going to use this theorem next section. A matrix invertible, that means there is inverse for this matrix if and only if the determinant for this matrix is not 0. This is really important. We're going to use this theorem next section. For number 4, in fact, this is another theorem. If A is invertible matrix, the system of linear equations represented by, here is our system, which is AX equal B. Now, if they ask you, has unique solution given by, the unique solution is going to be X equal the inverse for the matrix A times matrix B. So this one is going to be the inverse for the matrix. That means we have to choose this one. So we're going to choose A inverse times the matrix B. We got it right. Now let's move to number 5. For number 5, we already learned the matrix A. The inverse is going to be A inverse. This is the inverse of the matrix A. Now, if I multiply the matrix A with the inverse of the matrix A is going to be the identity. So that's how we're gonna write it down. For the inverse of the matrix A is going to be the identity. And if I multiply the inverse of A times the matrix A is going to be the identity matrix. So let's check that. With number 5, we have 2 matrices. A is 2, 1, 7, 4, and B is 4, -1, -7, 2. We need to prove that. They ask you, show that B is the inverse of A. We need to show that B is the inverse of the matrix A. So that means if we multiply A times B, we have to get the identity. And if we multiply B times A, we have to get the identity matrix. That's what we need to prove. So if we multiply A times B, so the first row times the first column, this row times this column. So 2 times 4 is going to be 8, plus 1 times -7, plus 1 times -7. And the first row with the second column, so it's going to be 2 times -1, 2 times -1, plus 1 times 2, 1 times 2. Now, the second row with the first column, that means 7 times 4, plus 4 times -7, 4 times -7. And the second row with the second column, so it's going to be 7 times -1, plus 4 times 2. Let's check how much is going to be the result for this 8. 1 times negative 7 is going to be negative 7, so 8 minus 7 is going to be 1. For this one, 2 times negative 1 is going to be negative 2, plus 2 is going to be 0. 7 times 4 is going to be 28. 4 times negative 7 is going to be negative 28. 28 minus 28 is going to be 0. 7 times negative 1 is going to be negative 7, plus 4 times 2 is going to be 8. So negative 7 plus 8 is going to be 1. So we already proved that A times B is the identity matrix. Now we need to prove that B times A is also the identity matrix. Let's do the same thing. So the first row with the first column, then the first row with the second column. So 4 times 2 is going to be 8. 4 times 2 plus negative 1 times 7. Negative 1 times 7. And the first row with the second column, 4 times 1 plus negative 1 times 4. Negative 1 times 4. This is the second element in the second column. Now the second row with the first column, so negative 7 times 2, negative 7 times 2 plus 2 times 7. And the second row with the second column, so negative 7 times 1 plus 2 times 4. Let's check the result for this one. 8 minus 7 is going to be 1. 4 minus 4 is going to be 0. Negative 14 plus 14 is going to be 0. And negative 7 plus 8 is going to be 1. So B times A is also going to be the identity matrix. That means B is inverse of the matrix A. So we're going to type here 8 plus negative 7, because we have to type everything here, minus 2, and here is minus 2 plus 2. So I typed everything. Let's check that. That's it for this example. Let's move to example 6. How to find the inverse for the matrix. So for example 6, I did all the steps. So let's see. Again, we already know like A times the inverse equal the identity. And the identity matrix for dimension 2 times 2 is going to be 1, 0, 0, 1. The identity matrix for 3 times 3 dimension is going to be 1, 0, 0, 0, 1, 0. And the same thing, keep going if you have dimension 4 times 4. So now I'm going to learn the first method to find the inverse, which is called Gauss-Jordan elimination method. How this method is work. Always, you need to write down the matrix you have to find the inverse, and write down, here's the slash line, and write down the identity matrix. For example, if we need to find the inverse for the matrix 2, 1, 9, 5. So here is the matrix 2, 1, 9, 5. And then put this line, and then I'm going to put the identity matrix, which is 1, 0, 0, 1. Now my goal is to work on this matrix. My goal is to work on this matrix, convert this matrix to the identity matrix. The new matrix is going to be here is the inverse. So that's, I did these steps. So if I need to convert this matrix to the identity, that means I need to convert this number to 1. So it's mean I'm going to divide the whole row 1 by 2. So that's what I'm going to do. Divide the whole row 1, not just this matrix, the whole row 1 here. So 2 divided by 2 is going to be 1. 1 divided by 2 is going to be half. 1 divided by 2 is going to be half. 0 divided by 2 is going to be 0. So here is my new matrix. I'm not going to look for this one anymore, because my goal is to find the inverse. So I'm going to write down this matrix here. Now the second goal is to convert the number here with this location to 0. So I'm going to say negative 9 times R1 plus R2. Negative 9 times R1 plus R2. So, but I'm going to do the change for the whole R2, not just for this element. I'm going to write down row 1 exactly the same. Now, negative 9 times 1 is going to be negative 9. A plus 9 is going to be 0. Negative 9 times half is going to be negative 9 over 2. A plus 5 is going to be 1 over 2. Negative 9 times half is going to be negative 9 over 2. A plus 0, so it's going to be negative 9 over 2. Negative 9 times 0 is going to be 0, plus 1 is going to be 1. So here is my new matrix. I'm not going to look for this one anymore. I'm going to write down this matrix here. Next step is to convert the element on this location, step 3, to 1. This is 1 divided by 2, is not 112. Now, if I need to convert this one to 1, I'm going to divide by half. 0 divided by half is going to be 0. Half divided by half is going to be 1. Negative 9 over 2 divided by half is going to be negative 9. And 1 divided by half is going to be 2. 1 divided by half, it's mean 1 over 1 times 2 over 1. So it's going to be 2 over 1, which is 2. So here is the new matrix. I'm not going to look to this one anymore. I'm going to write down the new matrix here. Now, the last step, I need to convert this number here to 0. So I'm going to say negative 1 over 2, which is half. So negative half, R2 plus R1. So this is still the same thing. Negative half times 1 is going to be negative half, plus half is going to be 0. Negative half times negative 9 is going to be positive 9 over 2. Plus 1 over 2 is going to be 5, because it's going to be 10 over 2, which is 5. Negative half times 2 is going to be negative 1. A plus 0 is going to be negative 1. So here is the new matrix. You see, this side now is the identity matrix, and the new matrix here is the inverse. That means my inverse matrix is going to be 5, negative 1, negative 9, and 2. If you want to check, if you multiply the matrix A times the inverse, you have to get the identity matrix. And if you multiply the inverse times the matrix A, you have to get the identity matrix. That means this is the inverse for this matrix. So we're just going to type here 5, negative 1. And you're going to type here, the second row is negative 9 and 2. That's it for this example. We got it right. Let's move to example 7. We're going to do exactly the same steps what we did in example 6. So example 7, here's the matrix. 1, negative 5, and 5, negative 4. So we need to find the inverse. So this is Gauss-Jordan elimination method, A, and here is the identity matrix. So here is the A matrix, and here is 1, 0, 0, 1. Now, our goal is to convert this matrix to identity. The new matrix is going to be the inverse. So for this one, it's already 1. So I'm going to skip this step. I'm going to go to this number, convert this number to 0. So I'm going to say negative 5 times R1 plus R2. That means the first row is going to be the same. Negative 5 times 1, negative 5 plus 5 is going to be 0. Now, negative 5 times negative 5 is going to be positive 25. Positive 25 minus 24 is going to be 1. Negative 5 times 1 is going to be negative 5. A plus 0 is going to be negative 5. And negative 5 times 0 is going to be 0, plus 1 is going to be 1. So here is the new matrix. I'm not going to look for this one anymore. I'm going to write down the new matrix. If you look to the new matrix, the third step is to convert the number to this location to 0. To 1. It's already 1. Now, see, I'm going to skip this step. I'm going to go to step 4. convert this number to 0. So I'm going to multiply R2 by 5 and add it to R1. That means 5 times 1 is going to be 5, plus negative 5 is going to be 0. 5 times negative 5 is going to be negative 25, plus 1 is going to be negative 24, and 5 times 1 is going to be 5, plus 5. 5 times 1 is going to be 5, plus 0 is going to be 5. You see, this side is the identity matrix, and the new matrix here is going to be the inverse matrix, the inverse of the matrix A. So here is the inverse. Again, if you want to check that, you can multiply A times the inverse, you're going to get the identity matrix, and you can multiply the inverse by the matrix A, you have to get the identity matrix. So that's it for example 7. So we're just going to plug in here negative 24, and here is 5, and here is negative 5, and here is 1. That's it for this example. You got it right. Let's move to number 8. Number 8, now we need to find the inverse for 3 times a 3 matrix. So I did the steps. Let's check that. So here's for number 8. We're going to do exactly the same steps, but now we have a 3 times a 3 matrix. So here's the matrix 1, 1, 1, 4, 6, 5, 4, 7, 6. I'm going to do the same thing, write down the matrix with the identity. Now my goal is to convert this matrix to the identity. The new matrix is going to be here is the inverse. So let's start with the first step. Step 1 is to convert the number here to 1. It's already 1. So I'm going to go to step 2, convert this number to this location to 0. So I'm going to multiply negative 4 by the first row and add to second row. So I'm going to do the change for all this row here. So it's going to be 0, 2, 1, negative 4, 1, 0. Now, this is my new matrix. I'm going to cancel this one, write down the new matrix here. Now, the second goal is to convert this number to this location to 0. So I'm going to do the same thing, negative 4 times R1 plus R3. Here is the new matrix. That's what we got. That's mean I'm done from this matrix. I'm going to write down the new matrix here. Now, next step. Next step is to convert this number to this location to 1. So I'm going to divide by 2. That means 2 divided by 2 is going to be 1. 1 divided by 2 is going to be half. Negative 4 divided by 2 is going to be negative 2. 1 divided by 2 is going to be half. And 0 divided by 2 is going to be 0. So this is the new matrix. I'm done from this one. I'm going to write down the new matrix here. Now, next step is to convert this number to this location to 0. So I'm going to multiply the second row by negative 1 and add it to row 1. That means the change is going to be on the first row. So 1 is stay 1. This one is going to be 0. This one is going to be half. This one is going to be 3. This one is going to be 0. And this one is still 0. So here is the new matrix. I'm done from this step. Here is the new matrix. Now I need to convert this number to this location to 0. So I'm going to multiply R2 by negative 3 and add it to R3. The change is going to be on the third row. The first row and the second one is going to be the same. So this number has become 0. Now it's half, 2, negative 3 over 2, and 1. So this is now the new matrix. I'm not going to look to this one anymore. I'm going to write down the new matrix here. Now, next step is to convert the number to this location to 1. So I'm going to divide by half. Half divided by half is going to be 1. 2 divided by half is going to be 4. Be careful here. 2 divided by 1 over 2, which is mean 2 over 1 divided by 1 over 2. So it's mean write down 2 over 1. Take the reciprocal for the second one, which is 2 over 1. So the result is going to be 4 over 1, which is 4. That's why we get 4 here. And 2. So now this is the new matrix. This one is the new matrix. I'm not going to look for this one anymore. I need to do 2 more steps to get the identity matrix here. So here is the last step we have. Now I need to convert this number to 0. So I'm going to multiply R3 by -½ and add it to R2. The change is going to be on R2. We got 0, 1, 0, -4, 2, and -1. That means I'm not going to look for this one anymore. This is my new matrix. Let's keep going. Now, next step, I need to convert this number to this location to 0. So again, I'm going to multiply by -½ R3 plus R1. So we're going to get, here is the identity matrix. Let's say just identity 3 times 3. And here is our matrix, which is the inverse. The inverse matrix is going to be here. Again, if you want to check, you have to multiply the inverse by the matrix, the original matrix, you can get the identity. And the same thing for the inverse times the original matrix. And the matrix times the inverse is going to be the identity. So we're going to type here for this example is 1, 1, and -1. And -4, 2, -1. And here's going to be 4, -3, and 2. That's it for this example. You're gonna try. You're gonna do the same thing for number 9. And be careful for number 9, if you step on certain location, when you need to convert this number or the new number here, and you can't find it, so in this case, there is no inverse for this matrix. And in this case, you're just gonna type does not exist. Does not exist. So you have to check example 9. For example 10, they're asking you to use this formula. And you will see we're going to use exactly the same formula next section, or section 10.5. So the same formula here. So now for any matrix, matrix A, the element for this matrix is A, B, C, and D. So here's the elements for the matrix. So if they ask you to use this rule to find the inverse, keep in your mind, here's the matrix A, B, C, D, so I can use this formula. If you change the location, you're gonna get something wrong here, and you're gonna get the wrong answer. So here is the formula, and here is the matrix A, B, C, D. So let's use this formula. That means this is A, this is B, this is C, and this is D. So what I'm going to do, I'm going to use the formula. The formula says 1 over AD. So here is the A, and here is the D. So A times D, that means 3 times 5, minus B, this is B here. So B is -1 times C. Here is the C, which is 2. Now I'm going to open this bracket for the matrix. I'm going to put D here. D in this location, I'm going to put it here. So it's going to be 5 and negative B. So where is B? This is B. So negative this number. Be careful here. Negative B. Then I'm going to put here negative C. So where is C? This is C. I'm going to put negative C. And here I'm going to put A. A is this number. So here's A. So be careful when you do the numbers. My advice is for you is to write down here the matrix A, B, C, D, So you can know this is A, this is B, this is C, and this is D. So you're not going to do mistakes. So now let's check. That means our inverse is going to be 1 over 3 times 5 is going to be 15. Negative 1 times 2 is going to be negative 2. Times negative is going to be plus 2. And here is going to be 5. Negative times negative is positive. And here is negative 2. And here is a 3. That means this one is going to be 1 over 17, 5, 1, negative 2, 3. This is the inverse. Now we have to multiply because this is a number times the matrix. That means the inverse is going to be 1 over 17 times 5. So it's going to be 5 over 17. 1 over 17 times 1 is going to be 1 over 17. 1 over 17 times negative 2 is going to be negative 2 over 17. And 1 over 17 times 3 is going to be 3 over 17. So this is the inverse for the matrix A by using this formula. So we're going to type here 5 over 17, 5 over 17. And here 1 over 17, 1 over 17. And here negative 2 over 17. And here is it 3 over 17. That's it for this example. Let's move to example 11. I'm going to do the same steps for example 11. We have to use the formula to find the inverse for the matrix. So we're going to do the same thing. So here's 11. So this is negative 4, negative 6, 2, 3. So what I'm going to do here, again, I've told you do exactly the same thing. Write down the matrix here, so you're not going to do any mistakes. Now the inverse is going to be 1 over AD. This is A, negative 4 times D, which is 3. So negative 4 times 3 minus BC. So B is negative 6 times C, which is 2. Negative 6 times 2. And here is the matrix we have here. We have to write down D, which is 3, negative B. So here is negative B, that's mean negative, negative 6. And we have to write down negative C, that's mean negative 2, and A, which is negative 4. Now let's check the inverse here. It's going to be 1 over negative 4 times 3 is negative 12. Negative 6 times 2 is negative 12. Times negative is going to be plus 12. And here is a 3. This one is going to be 6, negative 2, and negative 4. Now, next step, the inverse is going to be 1 over 0, because negative 12 plus 12 is going to be 0, 3, 6, negative 2, and negative 4. 1 divided by 0 is undefined, because you can't divide any number by 0. So this is undefined. That means in this case, there is no inverse for this matrix. So we're going to type does not exist. For example 12, now what we're going to do with example 12. For example 12, before I start doing this example, we have some notes. For any system, here is a system of the matrix AX equal B. X is going to be A inverse times B. A inverse times B. So this is for number 12. We have the inverse matrix A negative 1. So let's see what they ask you. They're telling you use the inverse matrix This is the inverse matrix to solve the system. That means we have the inverse. Here is the inverse matrix. We need to solve the system. So the only thing we need to locate is B. So the first thing what I'm going to do, here is the system, x minus 2y equal 2 and 2x minus 3y equal 4. So first of all, I'm going to write down the system. The system that means A, x equal B. So the matrix A for this one is 1, 2, -2, and -3 times x equal the matrix B, which is 2, 4. The only thing I need here is the matrix B. So I have B equal 2, 4, and I have the inverse matrix A inverse, which is -3, 2, -2, and 1. Now we need to find the value of x, so I'm going to use the formula. It says Ax equal inverse matrix times B, which is mean x equal A inverse -3, 2, -2, and 1 times B, which is 2, 4. And let's do the multiplication. That means x is going to be equal -3, the first row times the first column. So -3 times 2 is going to be -6, and 2 times 4 plus 8. The second row with the first column, so -2 times 2 is going to be -4, plus 1 times 4 is going to be 4. Let's add these two matrices. So x is going to be, so two numbers, -6 plus 8 is going to be 2, and -4 plus 4 is going to be 0. That's mean the solution for this system is going to be 2, 0. So we're going to type here 2, 0. That's it for this example. You're going to do the same thing with example for 13. Now let's go to example 14. For example 14, we don't have the inverse matrix. Use the inverse matrix to solve the system of linear equations. So we have the system, but we need to use the inverse to solve the system. So here is the system, 5x plus 4y equal 3, and 2x plus 5y equal 8. Ax equal b, that means this is the matrix A, which is the coefficient here for x and y, and here is the matrix B. Now, here's the matrix A, I need to find the inverse. So I'm going to do exactly the same steps with example 6. 5, 2, 4, 5. I'm going to put 1, 0, 0, 1. The first thing, I need to convert this number to this location to 1. So I'm going to divide by 1. So it'll be 1, 4 over 5, 1 over 5, and 0. The second step, this is, I'm going to cancel this matrix. Here is my new matrix. The second step, I need to convert this number to this location to 0. So I'm going to multiply row 1 by -2 and add it to row 2. So here is the change on the new R2. This is the new matrix. I'm not going to look for this matrix anymore. So here is my new matrix. Now I need to convert this number to this location to 1. So I'm going to divide by 17 over 5. It's going to be 1. 2 over 5 divided by 17 over 5 is going to be -2 over 17. And 1 divided by 17 over 5 is going to be 5 over 17. So here is the new matrix. I'm not going to look for this one anymore. Here is my new matrix. I need to convert now this number on this location to 0. So I'm going to multiply -4 over 5 by R2 and add it to R1. So here is the new matrix. I'm not going to look for this one anymore. So that's mean here is the identity, and here is the inverse. Here is the inverse. Now To find the solution, X equal the inverse of matrix times B. So here is the inverse of the matrix times B, which is 3, 8. So the result for this one, you have to do the multiplication, the first row times the first column, and the second row times the first column. So the result is going to be -1 and 2. What's mean? We're going to type here, for example, 14, -1, comma 2. That's it for this example. For example, 15. So if you look to this system, first of all, be careful. There's a missing I2 here and I1 here. So when you write down the system, you have to be careful. So let's check this example. So here's example 15. Again, you have to be careful for the missing terms. So we have missing I2 here. So when you write down the system AX equal B, so you see this is 2, I2 is 0, and here is 4. 0, 1, 4. 1, 1, -1. And here is the X, and here is the B, because they're telling you here, this is E1, and here is E2. And then they're telling you E1 is 29, and E2 is 31. So I plug in 29 and 31 here. 29 and 31 here. So I have the B. Here's the matrix A. So I did exactly the same steps, for example, 8, and I get this matrix, which is the inverse. So here's the inverse for the matrix A. Now, X is going to be equal the inverse times the matrix B. Here is the inverse times the matrix B. So the result is going to be 3/2, 5, and 13/2. So I think you're going to use exactly the same inverse matrix. You just have to multiply it by the B, because you're going to get exactly the same system. So now this one is easier for you to solve. And we just have to type here, I1 is going to be 3/2. And for I2 is going to be 5. And here's 5. And I3 is going to be 13/2. 13/2. So again, this is going to be I1, and this one is I2, and this one is I3. So that's it for this example. We got it right. That's it for section 10.3.